Hi, Mina.
Hi,
How are you this year?
I'm good. How about you?
Good. So what kind of math has the new year brung?
Compounding interest and exponentials.
Okay. You have some problems that you can verbalize?
You invest $25,000 in a 3-year, 2.5% CD that is compounded continuously. How much money do you have when your investment matures?
Okay. There's 3 formulas that you need to memorize about compounding interest. One is yearly. That's the simple. Your amount is that times 1 plus the rate to the t number of years. The second one you need to memorize, I'm quite sure you're going to need this, is more frequently than yearly, more often than yearly. Tell me if I'm wrong. Have you covered this? Where K is the number of times you compound it. In other words, if you're compounding it, say, quarterly, every 3 months, you would be compounding it 4 times a year. K would be 4, and you would plug it in for that and that. And finally, the continuous compounding is what? I think it's PERT, is the way I remember it.
Yeah.
Where P is your initial amount, E is E. I think it's PE to the RT, correct?
Yeah.
Like that. Or A sub 0, if we want to leave it in terms of that. So these 3, have you learned all 3 of these?
Yeah.
Okay, good. I thought so. Given that you're starting out with a continuous compounding one, I figured you had to have learned the yearly and the more often than yearly. And it's not often that an equation is defined that way, more often than yearly. But that's the way it is. Notice that if you were to compound it continuously, K is infinity. In other words, doing it continuously is an infinite number of times per year. And if I plug in K going to infinity into the middle equation, I end up with this. That's how I get E into the picture. So, for our problem, we've got 25,000, a rate of 2.5 and 3 years. So we just have to pick the right one to plug it into. What do I need to put in here?
1 plus...
What's A sub 0? Remember, we're using the third one for continuous compounding.
25,000.
Right, that's the principal amount.
And then 0.
Well, the sub 0 that I write here merely means that's the initial amount. I can call it A sub 0, I can call it P, the principal. I don't know what your class calls it. What do you use, P or A sub 0 or something else?
We use P.
P? Okay. So P is the principal amount. Okay? And what's the rest of it? E to what?
0.025.
Yeah. In other words, you have to convert that percentage to a decimal. T is measured in years. So whatever this number comes out to be, and you need a calculator to figure that out, take e to the 0.075 power, multiply that number by 25,000, and that's your amount. Do you have a calculator in front of you?
Yeah. I got 26,947 and 10 cents.
26,000?
Yeah. 947.
Now, the last step of these kind of problems is to do a ballpark check. If that number was 2,694, would it be right? No, we know that the result has to be a number bigger than 25,000. We're investing $25,000 into this thing. We expect it to grow. So that makes sense. 26,947. We made a couple $1,000s in interest over 3 years. It's not bad at that low interest rate. So it passes the ballpark check. What kind of calculator do you use?
TI-84 plus.
Look what I found online. Hopefully it won't crash my whole program. A virtual TI-84 plus for free. You probably paid $200 for yours just like I paid $200 for mine. And I just found this the other day. Over the holidays I found this. Just for people who needed help with their calculator, I figured it'd be nice to have one of these. So if you have any calculator questions, I've got a virtual one now that I can put on the screen. I don't have to always use Wolfram Alpha like I did before. All right, what else you got tonight?
A bank offers 3 different 10-year car loans. Loan A is 5.5% compounded annually. Loan B is 5.3% compounded daily. And loan C is 5.1 compounded continuously. If you want to borrow $15,000, which loan is the best deal?
Okay. How are we going to solve this?
Would it require different equations?
Yes. In other words, we're going to put each of these percentages into the appropriate equation of these 3. I'll use P for all of them. Okay, so let's do the yearly. Annual was 5.5. So let's figure out what the total This sounds to me like you've also maybe been given the other 2 formulas for amortizing a loan or not. I actually think we can solve this problem with just these 3 equations. I might be wrong, but I don't think so. In other words, the yearly offer is 5.5%. Okay? So let's plug that into the yearly formula. It's $15,000. It's the principal amount that you're borrowing. You're paying 5.5%. for 10 years. That's going to produce a number. The second choice is daily, but they're only going to give you 5.3%. So tell me what I should write to plug in for this one.
15,000 plus 1 plus 0.53, I believe.
What's K?
And then over 365.
All to the...
10th power.
No, it's to the K.
10 times 365.
Right, so it's 3650 power. That's going to produce another number. And now let's do the continuous compounding, which is at 5.1%. So that would be 15,000 times e to the 0.051 times 10 power. So those are your three equations. You know how to, let's have you do that on your calculator. Come up with the first one. What's 1.055 raised to the 10th power multiplied by 15,000 equal to?
25,622 and 16 cents.
Okay, how about the second one? That's a little tougher to do. On your calculator, you might have to do it in pieces. If it was me, I would do this, what's 0.053 divided by 365, add 1 to it, take that number to the power of 3650.
25,483.
And finally, the last one. Take e to the 0.51 power, multiply that by 15,000.
Uh, 24,979 and 38.
24,000 what? 900?
And 79.
Okay. Now, if you were investing $15,000 and they gave you those three choices, which one would you pick?
The first one.
Yeah. So now the fact that they're lending you money, which one are we going to pick?
Wouldn't you choose the first one?
I think we got to choose the third one. Because we're borrowing money, we're basically, if we choose the first option, we're going to pay back $25,622 because the bank is going to base our entire loan on that formula. Right? The bank is on the other end. The bank is the one that is investing $15,000 with us. They're giving us $15,000. They want their money back at the end of 10 years. So the more money that we pay them back, the worse off it is for us. So I'm going to choose this one right here. That one means I only have to pay back $24,979 over the same 10-year period. Now, having said that, in my pre-calc book, there's a couple of other formulas that you use when you're figuring out loan value and present value. Have you done that? Have you looked at or worked with those other formulas?
No.
Okay, good. Because I'd say only about 10% of my students ever get to that part. most pre-calc classes don't get to that. So we can use these three to solve this problem. We don't have to look at loan value. Loan value is a real complicated. I'd have to actually open my book and find out what that formula is. All right, what else you got?
The population of lemurs in Madagascar is increasing at an annual rate of 2%. If there were 20,000 lemurs in Madagascar in 2000, how many lemurs are there in Madagascar today?
2% per year?
Yeah.
Okay. Which of those formulas should we use? Well, read the problem again. Because you didn't say per year the first time, and it actually matters.
The population of lemurs in Madagascar is increasing at an annual rate of 2%.
Okay. So it is 2% per year. So what's our formula going to be? First of all, it's since the year 2000. So we're at the year 2015. So my population, let's call it, what do you put on the left? You put A or you put Y or?
Put A.
So A equals the initial population, 20,000, times what?
One plus 0.02.
So that adds to 1.02, and what's the exponent?
15.
So that is what the population increases to, whatever number that is. Now, in reality, populations tend to increase continuously, but they went out of their way to tell you it was an annual increase of 2% per year. Had they said that it increases at 2%, you could have interpreted that as continuous, and then we would have used the A equals PERT. But they definitely said at an annual rate, so we can use the annual growth exponential equation. The only real question with this problem, yeah, the exponent definitely should be 15. In other words, 2001 would be 1 year. So if we subtract that minus that, we get the number of years. Okay, what else?
A new insect poison has been tested on mosquitoes and kills 85% of the mosquito population in an infected area every year. If there are 7.2 million mosquitoes in Mississippi and the entire state is sprayed with poison, how many mosquitoes will remain after 10 years?
I didn't quite hear the first part. Would you read the first part again?
A new insect poison has been tested on mosquitoes and kills 85% of the mosquito population every year.
Okay. That's all I need. And what the question was, how many mosquitoes are after how many years?
10 years.
10 years. So the amount of mosquitoes left is going to be what?
So 7.2 million. and then 0.15.
The insecticide has an 85% success rate at killing mosquitoes.
Mm-hmm.
How many mosquitoes are going to be left at the end of 1 year? 85% or 15%?
15.
Yeah. So this is 1 minus R, or 0.15. And notice that that makes a lot of sense, because at the end of 1 year, I would only have 15% of 7.2 million. So at the end of 10 years, what do you get? What's 0.15 to the 10th power multiplied by 7.2 million? It's pretty good mosquito eradication, I think.
None were left.
How much?
None.
None?
What did I do?
No, probably you didn't. But I'm not positive about that. Only because it would be hard to get to none. I mean, I could see getting to 1 mosquito or 2 mosquitoes maybe, but not none.
0.04.
Okay. 0.04 million. Did you multiply by 7.2 or by 7,200,000?
7.2 million.
So your answer is 0.04 million? Must be. Must be. It's not going to be 0.04 mosquitoes.
Yeah.
Okay. So when you have growth, it's always 1 plus R. When you have depreciation or decay, it's 1 minus R. And in this case, the R is 0.85. So every year we're losing, we're only going to have 15% of what we had the previous year. So after 1 year, we would have about 1 million. After 2 years, we would have about 0.15 million. So after 10 years, actually 0.04 sounds a little large. Shall I bring up my calculator here? Let's see if I can use this thing. So we want to do 0.15 raised to the 10th power, right?
Mm-hmm.
And then we want to multiply that by 7.2 million. None was correct. In other words, I got 0.04 mosquitoes. That's closer to none than it is 1. That's pretty amazing. How did you came up with none by doing this exact thing?
Yeah.
And you did multiply by 7,200,000, not by 7.2. Okay. Yeah, that 0.15 to the 10th power was an extremely tiny number. This designation here, do you know what this means? 5.766 times e to the minus 9th? That's times 10 to the minus 9th. So it's basically a decimal point with 8 zeros and then a 5, 7, 6, 6. And then even when we multiply that by 7 million mosquitoes, we still have less than one mosquito. Wow. Almost feels like I did something wrong, but maybe not. Do you have a last one you want to look at, or is that good?
I think I'm good.
Okay. And you want to do Thursday night, same time, 7 o'clock for a half hour?
Yeah.
Sounds good. Let me know. You know, I don't think last year we ever had you fixed for a certain day. I was looking, and we usually did Wednesday evenings. But if you decide that, you know, you want Tuesday and Thursday at 7 for a half an hour, you can lock those up, and I can lock them up so nobody else can reserve those times. I just don't know if your schedule is fixed enough that you want to do that or not. But let me know if you ever decide to do that. I can do it from my end. That's not something you can easily do from your end. Okay? I will talk to you Thursday at 7.
Okay,
All right,
thank you.
Bye-bye.